All right. Hello, Scott Hansen, Cisco Server Geek on Twitter here at VMworld 2013. I want to talk to you today about UCS and our converged infrastructure. I'll take you through some of the things that I tell customers, the value of UCS and what we see. So we'll just do a little whiteboarding on it. UCS, Unified Computing System. I like to point out that the S in UCS is not server. A lot of people think that we're making servers, which we are, but it's a holistic view about the whole converged infrastructure. So there's really three key points to UCS that make it unique in the rest of the x86 server world. So the first thing is unified fabric, right? So we'll just draw these out here. Okay, so what do I mean by unified fabric? If you think back in the day, so I've been doing x86 servers for 20 years now, right? Worked at IBM for a while, worked at Dell for a while, and when you look at the architecture of the fabric, right, back in the day when I was doing these things, we had multiple networking topologies, right? You had Ethernet, you had Token Ring, you had ATM, you had FIDI, you had all these different adapters. And not only that, you had all these different protocols on those adapters. So we're talking, TCP/IP. If you were doing NetWare, you had IPS, XPX. If you had Apple, you were doing Apple Talk, Banyan Vines, NetBEUI, NetBIOS. A lot of mess, right? And eventually, we said, hey, I think some things are just good enough, right? I don't care that I get maybe 2 or 3% extra performance on IPS, XPX. What if we just agree that Ethernet is good enough for everything, right? And TCP/IP is good enough for everything. And we all agreed on that, right? We said, hey, Ethernet and IP, that's good enough, right? The thing that wasn't good enough, though, was block level file protocols, right? You can't, during the time when we all said Ethernet and IP is good enough, that we're talking about 100 megabit, gigabit Ethernet, and there were not standards in place for block level file transfer. So we still had to have fiber channel, right? So we still had two separate things. We sort of converged on this, but we still had two separate things for storage. You fast forward to today, right? It's really just the great IT circle of life where things get bigger, better, faster, and eventually things become good enough again. So now we're at another point where, right, 10 gigabit, right, that's good enough to carry fiber channel now, right? So what we didn't have was standards in place to give us lossless Ethernet. So with the advent of DCB and DCE, we've got enough here to give us lossless Ethernet. So once you have lossless Ethernet, I can now take fiber channel, right, and do FCOE, right, over these same wires. So when I'm talking unified fabric, right, what I mean is one single wire that can carry all of this infrastructure. So that's the first key point. Right. The second key point is converged management. Right. So when you're doing a solution in x86 servers, you don't want to have different points of management all over the place, right? And that's what happened to us in the x86 server world, right? So when I was doing these things, we had just rack and stack servers and different points of management to touch things. And you don't get to a place where you've simplified your environment by adding more layers of complexity, right? So I used to work at IBM, and a lot of people ask me, right, why did you leave IBM, such a great company? I can tell you, back in the day, I was doing a briefing for a customer, and we were going through the solution, and I was talking about, hey, I'm going to simplify your world with my architecture. And what I was doing was, the customer was saying, hey, so I've got this problem. And I would say, oh, I've got this solution for you, right? It's, some IBM, Tivoli product that'll help you with some of your firmware updates, firmware management. And we continue the conversation, and then, the next thing you say, oh, I've got this other problem, right? So can you help me solve that? I go, oh, yeah, no problem. We've got another tool in the toolbox that'll help you do that, right? XYZ. And so this conversation continued through the whole briefing. And at the end of the briefing, I had talked to this customer about, I want to simplify your environment. And I had shown them all of these different tools that they would use to simplify the environment. And this guy leaned back in his chair and he said, whoa, you started this conversation by saying, hey, you're going to simplify my environment. You just laid out like a dozen different products. I don't understand how all these layers of, he said layers of crap, right? He used a different word at the time, and he was like, son, I just don't believe you, right? You can't tell me you're going to simplify my environment by adding more layers of complexity. And I had no answer for that guy, and that was pretty much the day that I said, why am I here, right? I need to look for something that's a little bit better. And that's what I decided to do, right? At the time, I just said, I'll just go to Dell because they make boxes and everybody's making the same thing, and let's go. So I was a little bit of stint at Dell, and then somebody showed me UCS, right? So in our world, this converged management, right? This is key, right? We don't have a management agent. We don't have management consoles like all the other vendors do. If you look at HP or Dell, they have separate management consoles, management agents. So it's just adding more layers of complexity. Ours is all embedded into the hardware, right? So that's the second key piece. The third thing is that makes UCS unique is stateless computing, right? This is really what drove me to come to Cisco, right? Because when let me show you some hardware here first. So let me get back to the unified fabric. So the way we implement this unified fabric, we have some top-of-rack devices that we call fabric interconnects, right? I affectionately call them FIs. If I say it real fast, it sounds like F5, but I'm saying FI, right, not F5. So the fabric interconnects handle that converged management and the unified fabric. So from these boxes, right, I've got chassis that then have I/O modules in the back that then connect up into the fabric interconnects, and then from that fabric interconnects, I do standard LAN and SAN connectivity out to the real world. So these, right? So when we get back to what I talked about with the unified fabric. So southbound of the fabric interconnects, this is an FCOE connection, right? It doesn't matter to the customer because there's no configuration. It's just a transport mechanism that we use to get through the system right up to the fabric interconnects, and then once it gets to the fabric interconnects, they break it up into standard LAN and standard SAN traffic. So these are regular uplinks that speak Ethernet and fiber channel, and they connect into your existing infrastructure, right? So they connect into the Brocades, the McDatas, whatever you have, right? It doesn't have to be. There's people think it has to be like a Nexus architecture. Not at all, right? This connects into what you have. We wouldn't have gained so much market share if we forced you to change everything. The great thing about this solution is I can connect up to 20 chassis that are all managed, right, through one IP address, through one management console. That gives me some great flexibility there. So that's the unified I/O piece of it. The way that the blades actually communicate is our blades, right? So this would be a blade. Our blades have what we affectionately call the VIC, the virtual interface card. So that virtual interface card has two legs. This is broken up into an A and a B fabric, right? So through this card, I'm actually able to instantiate up to 256 interfaces. And these interfaces can be either fiber channel or Ethernet, and any combination of, right? So if I want this blade to have 4 fiber channel interfaces and 12 Ethernet NICs, I can do that, right? And this is actually created as virtual wires, right, that ride inside that big 10 gig pipe, right? So I'm talking about that 10 gig pipe is good enough for everything. So inside of here, we'll have your Ethernet NICs and your fiber channel HBAs. The operating system, so if I have like ESX, I got vSphere installed on here, right? ESX is going to see regular fiber channel adapters and regular Ethernet adapters, and it's going to send regular frames, right? Just standard Ethernet and fiber channel packets to these interfaces. Once it gets to the VIC's going to wrap those up in FCOE, and that's what travels from the blades up into the fabric interconnects, and then when those packets get here, they get broken apart into regular LAN and SAN traffic. This is different than some other converged, right? You'll see some other CNA type adapters. You don't have the flexibility in those solutions to create up to 256 interfaces, right? That's a huge difference. And if you're coming from the regular rack mount server world, right, this is what we're all used to, that we all know and love. 2U rack mount servers that have 2 sides. This is what everybody's consolidated on. this is your virtualization building block that's been used by everybody, right? This is your R710, your R720, your 2950s, your DL380s, right? Regular, whatever. These servers, right? They are powerful enough to run, right? Sometimes hundreds of VMs, right? But what they don't have is enough I/O, right? So I've got enough memory and I've got enough CPU, but the challenge is getting all the I/O out of here. So what people had traditionally done is rack and stack 2U servers, and then Intel gave us these great things called quad port NICs, and we would load these up with quad port NICs in order to give me, right, enough interfaces to do vMotion, my data traffic, my backup, my FT networks, all that stuff, right? And that was just for the Ethernet, right? Maybe I even had a third one in there, right? And if I was connecting this to fiber channel, then I've got fiber channel HBAs that have their own set of wires so I can get my data stores in there, right? And then I also have my management interface, right, for my SIMC or my ILO that's coming out of there. That's just one server. It's like 16 or so cables, right? It's a flipping nightmare. You rack and stack all these 2Us, and you just have this wire mess of cable. So the thing that unified fabric really gives you, I mean, the first big advantage is obviously cable simplicity, right? I don't have as many cables coming out of the back. But the bigger thing that it gives you is if you wanted to make a change in this environment, you say, oh, maybe I need a backup network. I want to do some Veeam stuff. I want dedicated backup NIC. Maybe I didn't have enough ports on my top of rack switch, or I'm already using all my wires here, right? You'd have to pull it out, put in another adapter, or make some other whatever, trunk down another VLAN. It's inflexible, right? It's very inflexible. When you create these interfaces in software, they are very flexible. I can create, destroy, bring up, bring down, willy-nilly, right? So I've got all kinds of interfaces that I can just make ad nauseum at whim, right? So that's unified fabric, right? So that gets back to this, unified fabric. Converged management, right? That just means that everything management-wise is built in here, right? This is different than other blade solutions, right? I have 20 chassis that are under one management domain. If you look at other solutions, right, it's like this. You've got 14 blades in a chassis, and then you look at the back of the chassis. I'm most familiar with the Dell, so I'll show that, right? So you got the Dell chassis, M1000E, that's got in the back, right, an A, B, and a C fabric, right? And then that's replicated, so you have redundancy. So you got like an A prime, a B prime, and a C prime, right? So there's 6 switch module bays in the back of a chassis to provide the I/O connectivity that you need. The way it works, right? If the onboard Ethernet gets routed to the A slot, the mezzanine B gets routed to the B slot, mezzanine C gets routed to the C slot. So you got a lot of choices in what you want to do in that world. So not only do you have choices in Mez cards, you have a lot of choices in what type of switches do you want to put in there. Do you want it to be a Cisco switch? Do you want it to be a Force 10 switch? Do you want it to be a Juniper switch? Whatever. Not to knock on anybody, and right, this is just the way it works, right? But there is a 106-page I/O guide for the M1000E chassis that shows you all your options, right? I would argue that I really don't want that many options, right? We're getting to a point where stuff is good enough, like I said in the beginning, right? Stuff is good enough, big enough, fast enough. Why do I need all these choices? All I care about is, can I get the I/O I need for my applications? Can I get my fiber channel packets? Can I get my Ethernet packets from the application out to the network? The rest of it, like who makes it, how is it done, some little niche features on the edge, people don't really use that much of that. All I care about in my world is I have 2 I/O modules in the back of the chassis that handle Ethernet and fiber channel, right, up into the fabric interconnects. So it's a much more simplified environment, right? In this world, when you go to this, it's the 17th blade syndrome, right? If I have one chassis and I got 16 blades, not too bad. I go to the 17th blade, I have to replicate that whole entire infrastructure all over again just to get to the 17th blade. Very expensive to get new 10 gig switches, new fiber channel switches to make that whole world. And then what happens is now I have multiple things I have to manage, right? These each have their own chassis management controllers with their own IP addresses, and you have to manage those separately, right? The other vendors will tell you, oh, no problem, right? You want to manage all this as a holistic system. I have another tool that you can layer on top of that that will help with the management. But it gets back to the point I was talking about, where you don't simplify an environment by adding more layers of management and more layers of complexity, right? That just doesn't solve the problem. In our world, when these are 6U chassis, they hold 8 blades. When I go to the 9th blade, yes, I have to add another chassis, but all I have is 2 I/O modules and some cables, right? So it's actually much cheaper to build out this chassis than it is to replicate this whole entire infrastructure in other vendors' architecture. So we looked at that a long time ago, and that's why we decided to go this way. So that's the unified fabric piece of it. The third thing is really the stateless computing concept, and this is key. So in the rest of the x86 world, x68, I went in a time machine. I'm dreaming about my 68 Camaro. Woo! x86. So the rest of the x86 world, you have everything that defines a server lives on the server, right? If I want to know anything about this system as far as worldwide name, MAC address, firmware settings, BIOS settings, all that stuff lives on the machine itself. That means I have to either hit F1 to go into the BIOS, make my changes, F10 save and exit. It all lives there. In our world, our machines are stateless. So all the things that define the server actually live outside the server. They live in what we call a service profile. Right? So this service profile consists of 2 things. So there's really 2 things about a server that make a server what it is, right? There's things that have to be unique, right? I need to have unique MAC addresses, unique worldwide names. Those have to be unique. So what we do is we create resource pools, right? So resource pools have worldwide node names, worldwide port names, MAC addresses. My handwriting is getting really bad. UUIDs, the unique identifier on the motherboard. So we create pools of those that the service profiles can then pull those identities from. Then the second thing that makes a server unique is those things that you want to be the same across the server. So we make those as policies, right? So I've got policy, POL period. So with a policy, I define things like what's the boot order, right? I want that to be the same across every system. What are the BIOS settings? I want that to be the same across every system. So everything that needs to be similar is a policy. Everything that's unique is in a resource pool. Those things glom together to make a service profile. These service profiles live in the Fabric interconnect, right? They're simply XML files, right? So I have a service profile called maybe ESX01, right? And when I want to make that thing come alive, right? So here's my blade chassis. Let's say that in slot 1, I've got a blade that's like a 2-socket with 64 gig of RAM, right? If I want ESX to come alive, right, so in here it defines everything as well as, right, the NICs and the HBAs and how many of those do I have. I simply associate this profile, right, to that blade. And then what happens is that thing comes up, right, and I'm able to make it alive. If I need to make any change, say ESX01 needs to be, I want it to have like 256 gig of RAM. Let's say that users are loving it. I can change the association and bring it over here, all right? Since these are just files, very similar to VMs, I can move things around, I can copy them, I can clone them, I can replicate them, I can make as many as I want, all right? So that's it. So unified fabric, stateless computing with service profiles, and converged management. Those are the 3 things that make UCS awesome, that made me come to this company, and that are making customers purchase loads and loads of them. So it's great. So thanks. Appreciate your time.